Suppose that Janet intends to save for holidays by contributing $400 at the end of each month to an investment plan. At the end of every 3 years, she's going to withdraw $12,000 for a trip abroad. If the plan earns 6% compounded monthly, what will the plan's balance be after 7 years? Let's go ahead and set up a little chart to help us deal with this problem. What I've done is I've divided this into 3 columns. The first column is going to deal with the first 3 years of events. Then we're going to have that first withdrawal of $12,000. The next column is going to deal with the next 3 years of events. That'll lead us up to the end of 6 years, where we're going to have our second withdrawal. And then finally, we have to deal with that last year that'll get us up to the 7-year balance mark. So our goal is to figure out the future value over here at the 7-year mark. Let's begin by trying to figure out what happens over the span of the first 3 years. We know that in all cases, she's going to be contributing $400 at the end of every month. So I've gone ahead and I've put negative 400 in for all of our payments, as well as all of our PYs as 12. Next, we know that the plan earns 6% compounded monthly, so we can put in 6 for all of our IYs. And for the compounding frequency, we can put in 12 for all 3 of our columns. For our first column, we know that she hasn't really started with anything, so let's assume that the principal amount is going to be 0. And our goal is to calculate the future value. Now, how many equal-sized payments are made over the span of the first 3 years? Well, payments are happening 12 times per year, so 12 times 3 says we should have 36 equal-sized payments in this first column. So let's begin by getting 36 in for N, and then we'll get our interest rate, 6% in. Going into the sub-menu, I already have PY and CY programmed in as 12, so I'm going to go ahead and quit. Let's get 0 in for our present day value, and we'll put 400 negative in for our payment size. Let's go ahead and compute the future value. Future value should be $15,734.44. Now what she's going to do at the end of this 3-year period is she's going to take $12,000 of this. So let's go ahead and reflect that in our number here. And now what we have is we have the present value moving forward over the next 3 years. So what we're going to do is we're going to take this value that we obtained, let's change it to a negative and put it in as our present value for the next 3 years. So once again, our end value should be 36 because we're going to go through 3 years of monthly payments of $400. Everything else should be programmed into the calculator. So now that I have this 3,000 in for PV, I just need to compute my future value. And I get $20,203.38. Now recall that Janet here is going to take another $12,000 out in order to go on holidays at this point in time. So let's reflect that here just by subtracting our $12,000. And now we should have a value that we can put in for PV for the last remaining year. So I'm going to go ahead and I'm going to make this into a negative 8203. We're going to put that in for the PV. And for our remaining year, instead of 36, we do need N to drop down to 12. So we're going to make 12 equal-sized payments over the span of this last year. So I'm just going to update N by putting 12 in for N. Everything else should already be programmed, so now I can go ahead and compute my future value. So after 7 years, the balance in this account should be about $13,643.57.